Musk says that the first high-altitude Starship prototype just passed cryo-proof testing. SpaceX has begun installing 3 Raptor engines on the rocket for the first multi-Raptor static fire ever attempted. All eyes remain on Starship SN8's next-level test campaign, advancing the test program from 150-meter hops to high-altitude flights. Amid SN8's preparations at the launch site, and numerous Starships, at various points of construction, at the production site, several Super Heavy sections were observed during the week in advance of stacking operations for the first prototype booster. SpaceX CEO Elon Musk says that the first high-altitude Starship prototype, known as SN8, just passed cryo-proof testing in South Texas, potentially setting the ship up for a 15 km, 9.5-mile, flight test in the near future. Meanwhile, NASA astronaut Bob Hines recently overflew SpaceX's Boca Chica, Texas Starship factory with several compatriots, offering an excellent aerial view of the company's bustling facilities in the midst of Starship SN8's critical cryo-proof test campaign. Hines managed to catch the moon alongside one of the T-38 trainer jets NASA astronauts routinely use for training and travel, serving as a reminder that SpaceX won $135 million to build a lunar Starship that might someday return humans to Earth's lone companion. Likely with or without NASA's involvement, the Starship prototype production and test program SpaceX is deep in the midst of will directly determine if and when the company visits, and lands on, the Moon and Mars. Over the last 3 days, SpaceX has gradually put Starship SN8, the first prototype meant for high-altitude flight testing, through its paces, beginning with a seemingly aborted cryo-proof test on October 5/6. During the first attempt, SpaceX appeared to pressurize the rocket tank section with cold nitrogen gas and perhaps a small volume of liquid nitrogen before reopening the highway. Starship SN8 also actuated its large aft flaps under its own power for the first time on October 4, and SpaceX has performed several more actuation tests in the days since. 24 hours later, SpaceX tried again, this time successfully loading Starship SN8's liquid oxygen and methane propellant tanks with perhaps 1,000 metric tons of liquid nitrogen, used to simulate the ultra-cold temperatures of cryogenic propellant without the risk of a catastrophic fire or explosion. After cryo load, SpaceX reportedly attempted to pressurize the rocket's tanks to their limits, but the test was stopped somewhat short when Starship SN8 sprung a small leak near the engine mounts after reaching pressures of 7 bar, 100 pounds per square inch. Precisely as Musk predicted, SpaceX apparently managed to fix the minor leak in less than 24 hours and began the third round of Starship SN8 cryo-proof testing late on October 7. Once again, the rocket was fully loaded with liquid nitrogen and spent some 2 to 3 hours under cryogenic stress, as SpaceX likely stressed the thrust structure by simulating the thrust of Raptor engines with hydraulic rams. Nothing out of the ordinary happened, and Musk has yet to comment on the test, suggesting that things went largely as planned. Intriguingly, SpaceX then geared up for a fourth night of cryogenic testing on October 8/9. It's not entirely surprising that the company would want to test the first Starship built primarily with a new steel alloy as thoroughly as possible. If SN8's fourth night of testing produces satisfactory results and SpaceX is less than concerned with the leak discovered during the second round of testing, the company could be ready to install 3 engines and attempt the first multi-Raptor static fire test ever. SpaceX has begun installing 3 Raptor engines on the rocket for the first multi-Raptor static fire ever attempted. On October 9, the CEO revealed that the first SpaceX Starship prototype bound for a crucial high-altitude test flight had successfully completed cryogenic-proof testing after 4 full nights of work. Curiously, Musk didn't say much else, but past comments indicated that SpaceX would follow up a successful Starship SN8 cryo-proof test by installing 3 Raptors for the first attempt at a historic engine testing milestone, the multi-engine static fire. Starship SN8 was the first flight-worthy prototype to have functional aerodynamic control surfaces, flaps, installed, a milestone SpaceX passed on September 23. The rocket was rolled to the launch pad 3 days later but forced to sit at the pad for 4 days until high winds died down, at which point SpaceX was able to install SN8 on the launch mount. As speculated on October 1, it appears that SpaceX will indeed proceed with Raptor static fire testing before installing Starship SN8's nose section, reducing the schedule impact and cost of a hypothetical failure. Although modern computer simulations are far better than they used to be, there is still always some inherent risk present during the first multi-engine static fire of a rocket, as operating multiple rocket engines in close proximity can produce complex interactions that are hard to predict. Based on the fact that SpaceX has already shipped 2 Raptors to the launch pad, it looks like Starship SN8 will begin static fire testing with 3 engines installed, although there's still a chance SpaceX will sequentially proceed through 1, 2, and 3 Raptor tests. Regardless, SpaceX has yet to file for road closures for Starship SN8's first static fire test campaign. Based on past tests with Starships SN4, SN5, and SN6, the first static fire attempt could happen just a few days to a week after engine installation and will be preceded by at least 1 or 2 wet dress rehearsals, WDs, and Raptor spin prime and/or pre-burner tests. Per Musk, after the first successful static fire, SpaceX will inspect the rocket, and likely install its nose section, before performing another static fire to clear Starship SN8 for flight.